And welcome to 2.1, page 5. We just have a couple story problems on here. One I'm going to do for you. Second one I'll leave for you. And very real worldy here, because many times, as you can imagine, in real world setting, that you're going to have access to your calculator, because we can live with approximate answers most of the time in real world situations, or at least lots of times in real world situations. However, sometimes we actually need an exact answer, and it takes some handwork. So, height of the projectile of a football here. The height, y, and feet of a punted football is approximated by this messy little quadratic. But it's no less a quadratic. We have this upside down parabola. And we're supposed to go ahead and graph that. So let's go ahead and get to it here. So I've got negative. I'm going to use the fraction capability of my calculator. 16, cursor down, over 2025. Whoops. Try that again. X squared plus 9 on 5x plus 3 on 2. And double check always. Now, I'm in Zoom Standard. I don't think Zoom Standard is going to do me a whole lot of good here, just because of the very nature of this graph. But if I was just, say, go ahead, Zoom Standard. And here comes our football right there. And we really don't care about it to left of 0. And it almost just looks like very much looks like a straight line there. I need to go downfield some. So I'm going to go downfield, and let's see, this is in feet. Well, a football field's 300 feet long, and this is shorter than that. So I'm going to do this. I'm going to go window 0 to 300. And then if you have a reasonable idea what domain you want to use, a really neat option is this, zoom fit. So I could use zoom fit, or I could just set my y domain, because I suspect y is going to be above 0 and maybe less than 100. I'm not sure, but let's see what happens if I hit zoom fit. Right now it has to think out how high, how low do we have to go. So there's my football. See how it just makes the graph fit on there. And then it comes down, and really, bam, it just hit the ground. And we didn't need anything beyond that. But that's a pretty good picture of our graph right there. So our graph is, and I don't believe that's it. In fact, I know it's not 0 here, because when x is 0, we're up 3/2. So the ball's 1.5 feet off the ground when it's punted. So our graph, though, does look something like that. Okay? So how high is the football when it's punted? Oh, that's a heck of a hint. I wish they wouldn't have given it to us. In fact, we just talked about it. Find y when x equals 0. That's what it means. So that's the kind of thing that we should have to be interpreting. If I put this problem or a problem like it on a quiz or test, I would not give you that hint. How high is the football when it's punted? Well, when it's punted, it hasn't gone downfield at all. X is 0. Oh, it's 3/2. 3/2 feet high. What's the maximum height of the football? Well, the maximum height occurs right here. What do we want? The x coordinate here or the y coordinate? We want the y coordinate of that maximum. Now, they could have said, how far downfield is the ball when it reaches its maximum height, and then we want x. Well, we've got our calculator for this. That's a matter of finding the vertex, and I suppose we could complete the square on this and put this in standard form, but I think I'm going to take advantage of the calculator here. So second calc max, I need to get to the left of that maximum. I'm going to make sure I'm on the other side of it. For sure we are. I need to get to the right of it. I'm just giving it an interval to check. Enter. Yes, no, tell me. Hit enter one more time. and it says 104.016-ish. That's the Y value. So let's see here. What's the maximum height? 104.016 feet. Now, I think I've mentioned this, but worth mentioning again. Unless you're otherwise specified, we will round to 3 decimals as just a given rule here, because that's what they do on the AP Calc test, 3 decimals. I wouldn't be surprised if, in the real world setting, it's going to reach about 100 feet. Or at the most, that ball was 104 feet high. But we're going to round to 3 decimals just as a habit. And then how far from the punter does the football strike the ground? Well, the punter's on the ground. The ball strikes the ground here. We're looking for this. Common mistake is people will, I'm going to exaggerate this a little bit, they'll go from here to here. But I just want from here to there, and that is just that x coordinate. That's just the x coordinate of when it hits 0. So we could quadratic formula this. And it's going to be a bit of a mess. But we've got technology, SpongeBob. Let's go ahead. Let's go second calc 0. I'm going to stay to the left of the 0 because it's asking me for a left bound. Cursoring over. Notice cursoring up and down doesn't do anything. You always traverse the graph with right or left. Stay to the left, but get close. Enter. Get on the other side. Enter. Guess. Nope. Just tell me. Y value 0. The x is 228.642. .643 if we round it. And that's feet. That's really quite a punt in football. That's what, a 75-yard punt. Now that's from the point where the player kicked it, but that's usually, by the time he punts it, he's usually about 10 yards back. That's a pretty good punt right there. So anyway, there we have it. 66. Actually, there's a little bit less to do on it, but lots of questions we can ask. How high is the ball? If I threw a rock off a cliff, how high is the cliff? How high did the rock go? How far did it go before it hit the ground? Lots of questions we can ask that we have to just be able to interpret. So just one problem here, and that wraps up 2.1.